Hello friends, today let's solve three-sum problem. This is the extension of the first question of LeetCode, two-sum. And I think this is also a basic of many hard questions. The idea used in this question can be used in other hard questions. So I think it is a good question. So let's see the statement. Given array numbers of n integers, are there elements a, b, c in numbers such that a plus b plus c equal to 0? Find all unique triplets in the array, which gives the sum of 0. Let's see the example. The given array is -1, 0, 1, 2, -1, -4, and this is the returned result. So from this example, we can see that they can be duplicate numbers in the given array, and the given array is unsorted. So our task is to find three numbers that equal to 0, and their sum equal to 0, and we need to skip some duplicate triplets. So we can convert this question to two-sum. That is, for a given a, we need to find our target, which is two-sum equal to -a. So it at least is big O n squared, because we need to iterate all the elements to get this a, and for the rest part, we can at most do big O n. So in total, the fast solution should be big O n squared. As it may contain duplicate elements, we need to skip some elements when we iterate this a. So we need to sort the numbers first. And I think this is a frequently used formula, which is if the current index is greater than 0, if the number's index equal to its preceding element, we need to skip current element. For example, if a first equal to -1, and we already search all the possible combination, which is triplets, and then next a, we cannot let a equal to -1 again, because if we let a equal to -1 again, we will have duplicate triplets. So in this case, we need to skip its -1. Okay, so for the a, we need to find the two-sum equal to -a. If you have finished the two-sum question, you know we use a hash map to find the two elements. But in this question, as we already sorted this array, so we can use two pointers technique. As they already sorted, we can accomplish the two-sum question in big O n. We just put the low pointer of the next element of the a and the high pointer from the rightmost, and we get the sum of these two elements. If that equal to the target, we know it can be a result. And then we move this low high together. If the numbers low plus numbers high is less than the target, we want to get a larger sum, so we move low forward. The third case, if the numbers low plus numbers high is greater than the target, we should move the high backward. Okay, let's see the details. If this is the example, and we sort it first, so this is the a -4, so we need to find the two-sum. Target is 4, so current numbers low plus numbers high is equal to 1, which is less than 4. So we want to get a larger sum, so we move low forward. And then it's still -1, and the sum is still less than 4, so we move low forward 2, and keep on moving, and we failed to find this target. And then we move a forward, which is -1, and then currently the target is 1, and the low is -1, the high is 2, and the sum is 1. So we find it. So what's the next? We need to move low forward and high backward. Why? Because currently these two elements sum up to 1. If we only move one element, it can never achieve that target. We need to make one larger and make one smaller, so they can achieve the target again. And one more thing is that we need to skip the duplicates. You see, if currently is -1, if we just move one step, we still have -1. And we will find the -1 plus 2 equal to the target, but it's already contained in the result. So we need to skip these duplicate triplets. So we should skip all the elements equal to the previously low. And the same for the high. If it's equal to the previous high, we need to skip all the high. So this two part will be two while loop. And one more thing need to notice that if we need to move the low or high, we should always keep the low less than high. This is very important in the two pointers technique, and as well as in the sliding window. If we have two index to handle, we should always make sure the low less than high. But sometimes it can be equal. You should see the situation. Okay, this is the hardest part. Other two cases is quite simple. If less than target, move low forward. If greater than target, move high backward. So wipe up. To solve this question, we first needed to sort all the whole array and iterate all the A and try to find the two sum in the rest part of the array. Use two pointers technique. If they are equal, we should move both low and high and skip all the equal elements. Okay, now let's write the code. This is the result array list, and we sort these numbers, and we get the n equal to numbers.length, and iterate to get this a from 0, I less than n minus 2, because there should be a b and c in its right, so it at most can be n minus 3, numbers n minus 3, I plus plus. So quick check, if the numbers I is greater than 0, we just break, because this a is the smallest element in the triplicate. So if it already greater than 0, we can never find 3 elements sum to 0. And another thing, if the I is greater than 0 and the numbers equal to numbers I minus 1, we should continue. Okay, then we need to find a target equal to 0 minus numbers I. Okay, then low will be I plus 1, and high will be equal to n minus 1. Okay, so while the low less than high, we get the temporary sum will equal to numbers low plus numbers high. Okay, so if the temporary sum is equal to the target, we add it to the result. So result will add is also list. So we convert from arrays to list. So we build an array and pass the 3 elements, which is numbers I, numbers low, numbers high. And then we move low forward, and we need to skip all the equal elements. So the low less than high and the numbers low equal to numbers low minus 1. So low increment by 1. And while and we should move the high backward. And while low less than high, and the numbers high is equal to numbers high plus 1, let high minus minus. Okay, this is the hardest part. Another two cases is simple. It's two temporary sum less than target. We want to get a larger element, so we move low forward. Else, we move the high backward. So, in the end, return this result. Okay, thank you for watching. See you next time.